Hi, this is Stephen Brower from Irvine Community College. This is for CSIT 256, Computer Architecture and Assembly Language. There's going to be another video that's going to go through, and if you just look at the bottom here, the mul, the imul, the div, the CDQ, and the idiv. So there's another video that's going to be tackling those. With this video, what I want to show or talk about is the SHL, which is shift left, and the ROL, and the ROR for rotate left and rotate right. And actually, I just realized now the demo that I did is more the rotate right than it is the rotate left. Sorry about that. Okay, so up in Canvas, I'm sorry, before I get to the actual demo files, let's take a look at what SHL, which is shift left, does. So shift left will take a register and we'll move it so many bits to the left. In this example here, it's shifting everything one bit to the left. And so if this is the number that we're starting with, the 0 gets shifted one bit to the left. Now what happens is when we're filling in from the right, it's filling in with zeros. This bit 1 gets shifted 1 to the left, the 0 gets shifted 1 to the left, the 0 gets shifted 1 to the left, this 1 gets shifted 1 to the left, this 1 gets shifted 1 to the left, the 0 gets shifted 1 to the left, the 0 gets shifted 1 to the left. The rest of these are all zeros that are shifting 1 to the left. The leftmost bit shifts out, off, it's gone. The upper bits are not preserved in terms of a shift left. The net effect, or one of the things we can take a look at, well, let's see, 2 to the 0, 2 to the 1, 2 to the 0, 2 to the 1, 2, 3, 2 to the 4, 2 to the 5. Well, 2 to the 5 is 32, plus 2 to the 4 is 16, 32 and 16 is 48, plus 2 is 50. So the starting number here was 50. When we did a shift left, what we end up with is 2 to the 0, 2 to the 1, 2 to the 2, that's 4. 2 to the 3, 2 to the 4, 2 to the 5, that's 32. So 32 and 4 is 36. And then 2 to the 6 is 64. That's 100. So just by doing a shift of one bit to the left, our value went from 50 to 100. So a shift is a way that we can just do, in a sense, multiplication by a power of 2. So the demo file, so up in Canvas, I have this SHL demo, which I already have brought over here, this SHL here. And now what I did is I started with 25, and then I did a shift left, and then I displayed the decimal, shift left, displayed the decimal. And so what we're showing here is I started off with 25, I did the shift left, I got 50, I did the shift left, I got 100, I did the shift left, I get 200. So the shift left is something that can be used for multiplying by a power of 2. Okay, so what is, now what's going on here, and this is something, if I relate back to the demo, these bits here, these lower 16 bits have been loaded, and then a shift is being done to move it to the left. And so what I did in terms of the demo, if I come back here and load this one in, sorry. Now here I was just giving a starting point. EAX initially had all 3s, EBX had all 4s, just so we can see the stuff was being loaded in. These 8 bits are being moved into AL. These 8 bits are being moved into 8H. And what was there previously were all 3s. So what that corresponds to, there were all 3s, but then these lower 16 bits have been replaced with AL being this batch, and these collection of bits, and AH is these collection of bits. So that's what I have going on here. What I did next is I did a shift left 16 bits. By doing a shift left 16 bits, so bits got moved 16 bits up. So I'm just looking at it as a cluster to make it easier. The 0, 1, 0, 0 got moved here. This 1, 0, 1, 1 got moved here. The 1, 1, 1, 0 got moved here. The 1, 1, 0 got moved here. And the upper bits, they shifted out. They just shifted out to the left. Well, now that I moved the bits that were in the lower 16 up, I now can use AH and AL to load the lower 16 bits. And so that's what's happening here, is that once again we're loading AL and AH. And what that's going to do is that's going to load these lower 16 bits of that number. And so if I did it right, what's showing here, if we look at the top part, that the left part here, these 16 bits on the left, that was the same as these 16 bits on the left that were here. These 16 bits on the right were the ones that were just loaded in terms of these AL and AH here. Well, suppose I want to preserve the bit stream, but what I want to do is I want to take an upper set of bits but move it down into a register where I can refer to them as just as 8 bits. So ROR is for rotate right, and we're going to rotate right to the 8 bits. So this bit moves 8 bits to the right, this moves 8 bits to the right, so each of the bits are moved 8 bits to the right, the net effect being that these 8 bits here, which are in the lower 8 of the upper 16, which are not addressable directly as a register, then these 8 bits here move 8 bits down to this piece here, which is addressable as AH. On a rotate, whatever was on the right-hand side rotates around to the left. So these 8 bits on the right, 1, 0, 0, 0, 0, 1, 1, 0, now becomes here 1, 0, 0, 0, 1, 1, 0. So in the rotate, the bits are preserved, they're just in different positions. So suppose I now want to do something with this piece right here. Now I can address that subset of this 32-bit number. I can address just these 8 bits. So let's say I'm dealing with a peripheral, and this is some kind of a setting for the peripheral device. Now I can focus on just setting these bits in terms of the peripheral device. So in terms of this example here, after I did the rotate to the right, I took the AH, so I took just these bits here, I loaded it into EBX, doing a 0 extend, just so I can see that in the lower 8 bits of EBX should be the 8 bits, these 8 bits that were here. Okay, so if I try to run this, again, I'm talking in, well, I was copying and pasting, but let's look back to, in terms of the PowerPoint, is that this part up here, that was the bit stream, which is this piece right here. CEB4, 7586, 7586. So this bit stream here is being shown by the display of this hex digit here. Then when we did the rotate to the right, well, the rightmost 8 bits, 86, got moved to the, rotated around to the left-hand side. These 8 bits came down here. These 8 bits came down here. Well, these 8 bits that were here, the lower 8 of the upper 16, are now in the upper 8 of the lower 16, which is addressable as AH. So in terms of, I was taking the AH, so those 8 bits that were there, I loaded it into EBX and did a 0 extend. So if I look at this register dump, there's those 8 bits in there as well. So part of the chapter is showing that shift happens. I do realize earlier in the video I did misspell, or I misspoke shift, and I tried my darndest not to draw attention to it. Now that you're aware of it, I did misspeak. But the earlier part of the chapter is dealing with shifting and rotating, and there are other commands to get into. There's also the shift arithmetic left, the shift arithmetic right. I didn't go into those. I just did shift left and rotate right. I just went through those 2 examples as part of this video. So just jumping back here again. So what I in this video did was shift left and rotate right. And there's going to be another video that's going to address these other commands that are in the chapter. I don't have videos for what's here, of which the A's that are here are arithmetic. Shift arithmetic left, shift arithmetic right. But this is what we're looking at here in Irvine chapter 7.